Hi there. For this video, we'll be talking about radicals, specifically its basics and an overall introduction on it. So first, let's have this. We have x raised to a, and suppose that this index is rational. So that means that a can be written of the form m over n, where n is not equal to 0. So we can write this one as x raised to m over n. Now from here, this is where the concept of radicals come in. If we have this as the exponent, if we have a rational exponent, we can write it as the nth root of x raised to n. So this is now a radical. So to define some parts, the n out here stands for the index of the radical. Then this expression inside stands for the radicand. Then this symbol out here is called the radical sign or symbol, or it is also called surd. So these are the basic parts of a radical or a radical expression. Now, just a quick note. If we have here, say, this one, so there is no index present. If the index is not present, we automatically assume that n here is equal to 2. And we call this one the square root. So that is the most basic form of radical. So let's have some illustrations. Let's have square root of 4. If we get this one, we know that we can write this one as 4 raised to 1/2. And then we can write 4 as 2 squared raised to 1/2. Then by loss of exponents, we multiply this one. So we'll have 2 raised to 2 over 2, or simply 2 raised to 1 or 2. Let's have another example. Let's have this one. This is called the cube root of 8, or negative 8 rather. So we can write this one as negative 8 raised to 1 over 3. And then note that negative 8, this one is equal to negative 2 times negative 2 times negative 2. So we can write this one as negative 2 cubed raised to 1 over 3. Multiplying the exponents, we obtain negative 2 raised to 3 over 3, or simply negative 2 raised to 1, or negative 2. Now let's talk about the term nth root, which I was using a while ago, but more specifically, we'll first focus on the principal nth root. So let's write that one down. Principal nth root. So if we are given say x, and we are tasked to find its principal nth root, then what we do is we simply, since this one is n, we simply raise this one to 1 over n, or this one is equal to this one. So that's why we call this one the nth root of x. And since we're dealing with principal, we'll be taking the positive one. So is there a possibility that the outcome is negative? For sure, and we will discuss that later when we talk about the secondary nth root. So let's have this as an example. Let's have 16. To get its square root, the square here signifies n is equal to 2. So we'll have 16 raised to 1/2. And this one will have 16. Note that 16 is equal to 4 times 4. So we can write this one as 4 squared raised to 1/2. Multiplying the exponents, we'll have 4 raised to 2 over 2, or simply 4 raised to 1, or 4. So the square root of 16 is 4. How about if we are tasked to find the fourth root? In this case, our n is equal to 4. So we'll have 16 raised to 1 over 4. And then, note that, since we know that a while ago, 16 is equal to 4 times 4, or 4 squared, and we know that 4 can actually be written as 2 times 2, then we'll have 2 times 2 squared, or simply 2 squared, then we multiply the exponents. So this one is 2 raised to 4. So we know that 16 is equal to 2 raised to 4. So we'll write that one down. So we'll have 2 raised to 4 raised to 1 over 4. Multiplying the exponents, we'll have 2 raised to 4 over 4, or simply 2 raised to 1, or 2. So the fourth root of 16 is 2. So that is how the principal nth root works. Now let's talk about some cases specifically on the nth root. So say let's have the nth root of x out here, or x raised to 1 over n. Now let's have our first case. So we have case 1. So our first case is that n is odd and x is any real number. So for this case, if n is odd, then our only possible nth root is only 1. So take note of that one. So it's right here. 1 possible root. So as an example, let's have 3, or the cube root of negative 125. Note that negative 125 is equal to negative 5 cubed. So this one can be written as negative 5 raised to 3 over 3, or simply negative 5. and that is the only possible root out here. We can't take 5 since 5 cubed is equal to 125, which is not equal to negative 125. So indeed, negative 5 is the only possible root of this one. Let's have our second case, or case 2. Suppose now that n is even and x is positive. Now from here, the possible roots out here is 2 possible roots. So the 2 possible roots out here is the principal and the secondary root. So to discuss that further, let's illustrate this as an example. Let's have square root of 25. Note that 25 can be written as 5 times 5 or 5 squared. So we can write this one as square root of 5 squared or 5 raised to, or 5 squared raised to 1/2, or 5 raised to 2 over 2, or 5. Now aside from 5 times 5, 25 can also be decomposed into negative 5 times negative 5. So this one is equal to negative 5 squared. So we can also write this one as square root of negative 5 squared, or negative 5 squared raised to 1/2, which is negative 5 raised to 2 over 2, which is negative 5. So as you can see, clearing this one up, the square root of 25 can be written as, or is equal to, positive negative 5. So the positive component out here represents the principal nth root, while the negative component out here represents the secondary nth. So take note of that. That is for n is even and x is positive. Now we also have another third case, since we haven't tackled one more, and that is if x is negative. What if x is negative? So let's clear this one, and this one. So our case 3 is x is negative. Now if x is negative, then we'll have an no real root. Indeed, if we say if this is even, then we know that, say if we have x and we raise it to n are even, say 2, like that, no matter what happens, the outcome is always positive. Since if we have negative times negative, that is equal to positive. And positive times positive is equal to positive. It's impossible to have negative times positive or positive times negative in here, since we're multiplying a number by itself. So there are no real roots out here, but there is an imaginary root. And that is what we'll be discussing in the next video. As an introduction to that one, we'll introduce the concept or the idea of I, which is equal to the square root of negative 1. This is the imaginary number. So that is, or these are the basics on radicals. Before I end this video, here are some exercises that you can work on to try out your skills on radicals, on getting the square root, the cube root, and such. So let's have first the square root of 225. Second, let's have negative 64 raised to 1 over 6. And lastly, let's have 1 over 4 raised to negative 1/2. So these are exercises that you can work on and try on by yourself. Then you can comment down below your solutions, your suggestions, your recommendations, and more specifically, your answers to these exercises. So that's it, and I hope you enjoyed this video, and I hope you learned something from this one. So that's it, and that's all for this video.